Good morning, one and all. My name is Megha Susan Matthew from S5EC1, and the topic for today's presentation is electrocardiogram. As we all know, electrocardiography is the process of producing an electrocardiogram. It is a graph of voltage versus time of the electrical activity of the heart, which is measured using electrodes placed on the skin. These electrodes detect the small electrical changes due to depolarization and repolarization of cardiac muscles. It is useful in capturing everything from small abnormalities in the heart rhythm, and hence it is called the golden standard for diagnosis of heart diseases. In this figure, we can see the first practical model of ECG, which was invented by the Dutch physician William Einthoven in the year 1895. As we can see in this model, for taking the ECG recordings, we had to place one of our foot in a jar which was filled with salt solution. This was how the first model of ECG worked. Now, coming to the working of today's electrocardiograph machines, it works on the principle that a contracting muscle generates a small electric current that can be detected and measured through electrodes suitably placed on our body. For a resting electrocardiogram, a person is made to lie in the resting position and electrodes are placed on arms, legs, and at 6 places of our chest at the area of our heart. The electrodes are attached to the person's skin through special jelly like structures. The electrode picks up the current and transmits them to an amplifier inside the electrocardiograph. Then, electrocardiograph amplifies the current and records them on a paper as a wavy line. Now, coming into the four major parts of ECG machine, they are the electrodes, connecting wires, amplifier, and a storage or transmitting devices. The electrodes in an EKG machine are basically of two types, the bipolar and unipolar. The bipolar leads are used to record the voltage difference between the wrist and the legs. Now, the basic physiology, electrophysiology of myocardial cells. Our heart cells have good automaticity, excitability, conductivity, and contractility. Automaticity is the ability to initiate an impulse, whereas excitability is the ability to respond to a stimulus. This stimulus can be internal as well as external. The conductivity is the ability to transmit an impulse, and contractility is the ability to respond with the pumping action. Now, the electrical conduction system of our heart. The sinoatrial node, which is present in the right atrium, which is also called the natural pacemaker of our heart, is the beginning of the electrical conduction system. Here is the portion where the electrical impulse is generated. Then it is transmitted to the AV node, then to the bundle of His, and then it is split into the left bundle branch and the right bundle branch. Then it reaches the apex of the heart, the Purkinje fibers. Now here it is given the different conduction speeds of our cardiac tissue. The different portions of our heart cells have different conduction rates, like SA node have 0.05, atrial path have 1, both AV node and bundle of His cells have 0.05 conduction rate, and the Purkinje system has 4, and the ventricular muscle has the conduction rate 1. Now, the ECG wave has four different parts, the P wave, followed by the QRS complex, and then the T wave. The P wave represents the atrial depolarization, that is, two atria are contracted. Then the QRS complex represents the ventricular depolarization, that is, the ventricles of the heart are contracting. Then the T wave represents the ventricular repolarization, that is, the ventricles are relaxed. Every depolarization is followed by repolarization, that is, every contraction is followed by relaxation. Now, here it is shown a single ECG strip which has a small box represent a big box representing 0.220 seconds, which has five small boxes, each representing the value 0.04 seconds. Now coming into the segments and intervals of an ECG wave. First is the PR interval. It represents the distance between the beginning of the P wave and the beginning of QRS complex. The normal value of the PR interval is 0.12 seconds to 0.20 seconds. It is measured by counting the number of cells between this PR interval and then multiplying it with 0.04. Then the QRS complex. The normal value of QRS complex ranges between 0.06 and 0.12. Understanding the basic circuit of electrocardiograph. This is basically for learning purpose. It has three different circuits: the differential amplifier, the notch filter, Butterworth low pass filter. First of all, the differential amplifier amplifies the recorded signal to a usable level to be displayed on the screen. This circuit design will take the difference in voltage from the two input electrodes and amplify it. This is done to reduce the noise as a common noise between the electrodes will be eliminated. Now we amplified our signal, but if we connect electrodes to this circuit right now, it would likely have a ton of 60 Hz noise. As a remedy to this noise, we use notch filter. A notch filter is designed to attenuate very specific frequencies and leave the other frequencies untouched. Increasing the resistance of R14 resistor will in R14 resistor will lower the attenuation frequency and vice versa. Now the low pass filter, another important factor is reducing the noise from our body. The goal of designing a low pass filter is to eliminate all signals that contains frequencies higher than the ECG. For this, we have to design a cutoff frequency so that here all frequencies above this can be eliminated. Our heartbeat occurs on the order of 1 to 3 Hz, and individual waveforms of the ECG ranges between 1 to 50 Hz. So, the cutoff frequency can be chosen at about 80 Hz. Now, these are the breadboard arrangements and components required in the above mentioned circuits. These circuits can be connected together to an oscilloscope to view the output, the ECG signal. The way in which electrodes are to be connected is shown in this picture. One is in the wrist, each one in two of the wrist, and the other one, the ground electrode is connected to our leg. Then there are different types of ECG machines. ECG machines vary in size, shape, and functionality. They all have the same working principles. They monitor patients' heart function and help to detect and diagnose abnormalities. Depending on your specific application, these will vary in type of data they are able to record and monitor. For example, a 12 lead standard ECG machine provides different views of the heart from varied angles. This is another type of ECG machine with Now, another type of ECG machine is handheld single channel ECG. The features and specifications of this ECG are shown. Like the specifications are the calibrating voltage is 1 millivolt, input current is less than 50 milliamperes, CMRR greater than 103 decibel, and so on. And certain features are like the lead selection are automatic and manual, operation mode is both automatic and manual, then display is of LCD. Such features are also given. And another type of ECG machine is digital single channel ECG, which is shown here. The features and specifications are mentioned below. Now, coming into the safety and sustainability aspects. Many performance testing, routine quality control audits, collection, etc., are done to ensure the safety and sustainability aspects. Then, Saving Direct is a program that enables the healthcare organizations to manage their reprocessing programs internally and to ensure the environment impact. Then, the maintenance of ECG machines. The maintenance can be assured by following these steps that after daily use, electrodes should be cleaned using copper alloy which can be done by soaking in saline solution. Then the battery operated ECG machines should be charged daily. Then we have to avoid heat, moisture, dust, etc. Then the device can should be checked in every 6 months, removing the dust and using compressed air. Then it is used in high humidity circuit boards can be dried with a blow dryer set on low heat. Then regular calibration should be done. The different manufacturers of ECG machines are shown. Aspel, Biocare, Cardioline, Customed, etc. are different manufacturers, and cost ranges are also shown. There are several limitations to the present ECG machine. For example, it reveals the heart rate rhythm only during the few seconds it takes to record. Then, uh, most of the times, the recordings are not accurate, especially when it comes to the detection of heart attacks. Results of an ECG examination are often unspecific, meaning that abnormal findings do not refer to one condition but could be the result of different problems. That is, the ECG variation do not particularly points out a single disorder or defect, but it can be different conditions, different problems. It can be resulting from different problems. Now, let us conclude. The ECG is one of the most important inventions and most useful tools in modern medicine. Medical and surgical centers use ECG machines because they are non invasive and quickly administered. But still, there are many modifications that are to be brought about in this field to eliminate the above listed limitations. So, for the better and accurate detections in healthcare, more researchers have to be promoted in this field. That's all about this topic. Thank you.